How's it going, you guys? It's Scott with Everyday Solar, and today I'm going to walk you through the DIY installation of a 5 kilowatt solar system that is roof mounted and also grid tied. Now, this is fully permitted and also needs to be approved by my utility for net metering. Now, although this is a fairly large project for most homeowners, you can save a substantial amount of money, sometimes $10,000 or more if you're able to take on a project like this. So let's go ahead and start marking out our layout of 2 separate arrays that will come together for that 5 kilowatts. So kick things off just kind of getting your plans laid out on the asphalt shingle roof. I like to use lumber crayons, red to indicate a perimeter, blue to indicate anchor locations, and a chalk line would come in handy to indicate the path of your rails. So you'll take your time with a screw in the first anchor locations as your reference point, and then you're measuring off of each of those locations for each of your rails that you'll need for your system. Okay, so now I have everything lined out here. The blue are my rails, and each mark shows my actual anchor locations. This is 8 total panels in landscape here, 2 rows of 3, and then the 3rd row of 2. This connects up then back here on the west side. So that's a southern facing roof. And then on the west side, I'm gonna have an additional 4 panels back here. And then those will tie together for the 4.8 kilowatts of overall output. Now, if you're already kind of completely overwhelmed, not knowing what size you need, where would you even put the rails, which side of your roof, where's shading at in the summer versus winter, there are a lot of factors, and there are companies out there that can help. Specifically, I went with Project Solar on this project, and overall it's been a smooth process and a ton of help. They helped me design the system, procure the hardware, get the engineering prints, submit for permits, and worked with the utility. So a ton of things that I didn't have to go through for the first time. I'll tell you more about them later on, but just know you don't have to do this all by yourself. And if you're interested, there's a link in the description, and there's also a promo code ES2024, which will waive the $100 deposit so you can get started right away. Now I'll be using the Iron Ridge Flash Foot 2, which is an awesome system. It gives you your flashing to give you that water resistance. You have your large lag bolt, and that's what's gonna go through. We need to make sure this is not just going in the decking, that it's actually securing to your truss or your rafter, giving it the strength we need. Once that's attached, then you just put that foot on there, and it can either be in the vertical direction or horizontal, depending on your design. The biggest thing for most DIYers, because you might be doing this for the first time, is how are you on the top of the roof, and you're gonna locate exactly where that truss is, so you make sure that lag bolt gets securely mounted. It can be a little tricky, and let me show you a few options for this first mounting I'm putting on the roof. So first step, we just need to understand our layout. I have the corner here marked, which is 36" from the edge here and 36" from the ridge. That's gonna give me my fire lane that's usually called out by your local code. Now from this corner, that's the panel corner. So I use a red lumber crayon to mark the panel corner, but I know my first rail is gonna be about 7 inches down from that edge, and then also about 6 or 7 inches over. So what I wanna do is just measure that off here. And I'm just gonna make some small marks roughly where I want to be. I'm not making my final location for this first foot because I just wanna roughly mark it in. So really about here. Now again, I can't just sink the lag right here and put the flashing in place because I don't know if I have an actual rafter here. So now we need to find where is the rafter located close to this position. And usually your rafters, get in your attic and check, but there should be center to center 24 inches, so 24-inch spacing. Just using a rubber mallet. Some people use a hammer. You're just hearing the sound as you lightly tap the roof. Okay, so this is more hollow over here. Man, pretty close to that spot. And then I go back to hollow. So again, I think we are pretty much right in this area. So it's up to you at this stage if you're comfortable enough to hit your pilot bit, a 3/16 drill bit, drill in to see if you're actually hitting that rafter. If you're just punching right through, nope, that's decking and you are a little bit off. Other people might use a construction screw, drive that in, and again, make sure that it's actually drilling in and tightening down well past the 1/2-inch decking. This would punch right through your decking, and then if you're using an impact driver, you would not hear the ratcheting action. I'll show you another method, but also make sure you understand your anchor points, right? I want this to be right in the middle of a course if I can on my roof. Because what the flashing does, and the best use case of the flashing, is for the first course to be exposed, go under the second course, and actually have some of the flashing going up under the third course. That is how you want to install this flashing. So we'll need to use a flat bar to peel up these courses and make sure we don't have any nails. So at this time I could do the pilot hole with the 3/16 of an inch drill bit. I'll go ahead and just start that. But remember, we're about 95% confident we're good to go. So how do you get to 100% confidence? Well, you could go into the attic and you could drill on the one side, leaving your drill bit popping up to know, okay, that is the edge. I have 1.5 inches for that rafter. Or you could use this little tool from Chip Tools that I got off Amazon. You'll see a link in the description. And what this is, it allows you to drill a pilot hole offset from your rafter and then place it in and rotate to hit the rafter and get a reference on the top of your decking on the middle point. So let's do that right now, and then we'll compare it to where we thought the middle point was. Okay, so I punched through and I did not hit my rafter. So now I sunk this inside and I'm just going to rotate it and I start to hit. So I start to hit the edge of that rafter. So what you want to do now is the wire is actually in the midpoint, and independent on your rotation angle, this gives you 3/4 of an inch offset. So this is going to be right in the middle here. Now I could reverse it down here and do the same thing. And I was pretty much right on. So I don't use this every time, but it's nice to have with me. So if I do miss one of these 53 anchor points I'm putting in, I can use this and correct my location, making sure I'm right in the middle. I also like to do this right on the first one, which pretty much was right where we were marking there. So we'll go ahead and finish that pilot hole. And then before we put the flashing on, let's go ahead and put some Henry's caulk here in the holes that we made. Now some people would do, let's say, like a horseshoe around those holes. So when the rain's coming down, you have kind of a bead that makes a little bit of a dam as the water comes down. Iron Ridge does not call that out on the design, so you don't have to do that. But if you wanted to, it's not going to hurt anything. We'll get everything lined up, and we'll go ahead and drive our lag. And then place our foot on. If it is 90 degrees off of what you want it, no problem, just go ahead and revert it there, and then you'll be able to click it into the place where I'll have my rail horizontally coming across. So I'll continue on here, and this is going to be the end points for the 6 rails on the southern facing roof, and that's going to have 8 panels in the larger of the 2 arrays. You'll need an anchor at each of the endpoints, and then you'll see once we continue to progress through, we will kind of alternate. The railing, Iron Ridge railing, calls out for 48-inch space between anchors along the length, but sometimes you will have 24-inch spacing there depending on what kind of span you have. But you'll see I'm alternating, and that's because we wouldn't want each of the anchors to be spaced 48 inches, because then you would be missing one of your rafters or trusses and not evenly distributing the load across your entire roof. So part of the design would be to have an alternating between the rafters and each of your rows, and then we'll be distributing the load correctly on your roof system. Now this is going to be one of the most time-consuming parts and kind of labor-intensive parts. So take your time, especially if it's a hot summer day like it is here while I'm installing it. Plenty of water because you're going to be putting in some work getting all these anchors securely fastened through your rafter system. And here I'll just be finishing up. This is the largest of the 53 anchors. I think it was about 30 some on this side. Now let's take a closer look at how to actually peel up the second and third cores. You'll have a flat bar. You probably want a thinner flat bar than this Milwaukee one, which is just a general purpose. The thinner it is, the better. It's going to help you peel up that tar strip that's adhered between the courses. And then you kind of slowly work it up so you're not ripping your shingles or damaging those to get that second course, and then ultimately the third course up, where then you can fit your flashing, make sure it can go all the way under, apply your caulk, and then set it in place, getting it lined up, and then sinking your lag bolt. Now we'll finish off all of our anchors. This is on the west side. This will be the smaller of the two arrays, only 4 panels, but again, I will need 6 overall rails to correctly mount 3 rows of panels. So one row is going to have 2 panels on the top here, and then just 1 panel on the second row and 1 panel on that third row. But again, you'll see there is an alternating across the rafters to make sure that load is distributed correctly. Now, if you're also looking at options for getting solar on your home to offset your monthly electric bill, professionally installed is what most people go, but there are these DIY options. Specifically to help me out, I went with Project Solar, and you'll see a link in the description where I started off. I gave a little information on my monthly utility bill and some details on my home, and just within a few minutes, they're able to start to size your system and give you some rough costs in what would that be as a DIY system, or they can actually connect you up with professional installers too, so you can compare and contrast the two options. Now, if I piece together everything myself, I probably could have saved a little bit more money, but they're helping me with the engineering prints, submitting my permits, working with my utility, selecting all the hardware. So there was a lot of value add, and I'm still saving about $7,000 to $10,000, paying about half price compared to professionally installed. So I think it is a valid option if you're willing to take on a project like this, which does have a lot of labor. But let me know what you guys think down in the comments. Would you take something on like this, or did you take something on like this DIY, and how did you go about that? Did you do it all yourself, or did you team up with a company? That's valuable feedback for me, but also valuable feedback for all the other viewers. So let's go ahead and jump back in and start to get our rails in place so we can mount the microinverters. Now the Iron Ridge rails will come in 14-foot sections, and then I'll loosely hand tighten the mounting bolts on each of the anchor locations. Getting the full length set out is easy enough, but I will have some sections there that will need to be cut, which I'll show you in a minute how I go about that. And then I have 2 full-length sections here on the west-facing roof that I'll set in place before moving on to getting everything squared up. Now I align this first railing 36 inches away from the side of the shingles, and then I start to tighten everything up. Then I will put a Sharpie mark from the end of each rails 30 inches in. That is a reference location, and you'll see me keep pulling diagonals with my tape measure. So I'm measuring that the diagonals are the same length, which would indicate I have a perfect rectangle from each of the rails. The first rail is my reference location, then I square up that second rail. Once that's squared up, then I go onto the third rail, and so on all the way through the 6 rails on this side. And I do that before splicing in the shorter sections because it just makes it easier to move those rails back and forth before anything's tightened up or that you have multiple sections going on your rail system. Now I'll need those shorter sections. I needed 4 sections of 64 inches in length and 4 sections 88 inches length. I just cut those with a Sawzall here, kind of a compact size Sawzall with a metal blade, taking my time, making sure the blade wasn't jumping around. And since these are aluminum, they're pretty darn easy to cut. Just take your time. And I do match factory edge to factory edge when I have to splice rails, leaving any cut edges on the open sides if at all possible. So now we have all our sections cut, we're ready to complete the rails. So bringing those together, Iron Ridge does make a small piece here that has these little clips on it. Those clips will cut into the anodized coating here on the rails and make sure we have a bond between both sides. So you just insert the one side, Then bringing in our new side, making sure it's on the right side of the anchor or the foot. Use a little rubber mallet. Then using the same mounting bolts, rotate those into place. You'd always want to have 2 feet on any section, so don't extend this out, only go into 1 foot. Make sure you have 2 on any section you're adding here. Use my little spacer to make sure my height is correct. So now we're getting into the wiring portion of the project, and specifically I'll be using microinverters. You might be using string inverters where you'd string together all your panels and then come into a string inverter. But for this case, we're doing the very popular Enphase IQ8 Plus microinverters, and these would fit panels from 235 watts to 440 watts. So a large range of applications would use this microinverter. You'll have 1 microinverter per panel. Your panel's DC output will come into these MC4 connectors, and then you'll be stringing together the AC output from each microinverter, which is a 240 volt out. And then that will all string together and then come down to your Envoy, your Enphase Envoy, which is the smarts of the system, but also what is called your combiner box. One thing that's easy to forget, there is some identification information for each one of these modules. You need to document that, and you need to document it on exactly what location you installed this module, or make a map of your exact array and then put that identification information, each one of those panels, exactly how you installed on your roof, and that will be used for your monitoring system later on and also help with troubleshooting. So if a panel or a microinverter is having issues, you'll know exactly the location, so you can remove that panel, start doing troubleshooting. And if you mess up on your identification and that location, that can be a pretty big problem for troubleshooting later on, because you'll think it's in the #1 position, but it's not, because somebody didn't do the map correctly. So take your time. Take a picture or another way to identify where you're putting each one of these microinverters on your map, so then they can use that later on for your monitoring system. Now, mounting is going to be super easy. You have 1 mounting bolt that will go right into the top of your rail, and then that will slide into this channel, and that's going to mount your microinverter. So it's really, really quick. Then I just mark about midway on each one of my panels on the rail, so I know exactly where to mount this, and then it makes the wiring that much easier later on. So pretty simple. I'll just make those marks right in the middle where my panels will line up, and then start to mount the microinverters at each of those respective locations, both on the southern facing array here, and then the 4 panels on my west facing array. So when we start the wiring, now because we don't have any panels on, we're a little bit away from that step, don't forget to start to get your Enphase Installer Toolkit app set up. You want to get an account set up, start registering the site, a lot of different details on this, because you're going to go around and you'll take an image through the app of each of your microinverters. So that is critical documentation that you need to know, in addition to all the details on your panels. The Enphase Enlighten app is going to hold that for you. That's where you're going to monitor the system and have all of those details for the future, which you're going to need if you ever need to troubleshoot or just information to reference on this exact installation. So now you can start setting that up and then go around and start capturing all the serial numbers on each one of the microinverters, even before you start wiring. So I've done that, and now we're moving on to the Easy Solar junction boxes that we'll actually be installing here on the roof. It has flashing, and similar to our Flash Foot 2 from Iron Ridge, you're gonna want the top of the flashing up under the 3rd course. We're gonna actually have to cut out a little bit on the 2nd course, and then that 1st course down here, we're gonna have the exposed junction box. I already pre-installed what are called gland connectors. So that's gonna pass the 240 coming out of our Enphase microinverters, and then also our bare copper ground, which is grounding each of our 3 rails on this side, and the same on my west facing side. And then because we've already attached all these anchor points, we know exactly where our rafter locations are. So I can go ahead and tuck this under my last panel here, so it's easily accessible in the future for any troubleshooting or maintenance work that we need to do. But it's also covered by the weather, so I'll have a panel over top of it which will be shielding it from any weather. So we'll get these installed and start wiring everything up and bring that together in the attic into a 4x4 metal junction box. So you get your exact location lined out and do some marking here with the lumber crayon. Use that lid to the actual component that you need to cut out on the second course. So we'll work that up with the flat bar just like we did for all of our flash foot 2s in the Iron Ridge anchor locations. And then we'll use a razor blade to kind of cut out that one section, which is going to give us room for the actual junction box itself on this easy solar junction box. And then you'll just insert that in. If everything looks good, you might have to pull a nail out like I have here. So working up that third course, finding the nail, and then removing that nail. So now you'll have the clearance to make the flashing go all the way up under that third course. Then I just drilled one little location so I can see it in the actual decking, and then use an 1 1/8" drill bit or spade bit to drill that out, and a stepper bit to drill out a smaller hole on the actual junction box. Why am I doing this? Because I'm inserting in a little a PVC fitting that will serve as a bushing for my 10-2 Romex coming up through the decking of the roof. So I'll do a dry fit. Everything looks good. Once it's good, then you'll use that Henry's roofing caulk to seal where the pre-line is, so it shows you exactly where to put the sealant. Once you have that in, then we'll have 4 internal mounting screws that will hold this to the wood decking. So that's pretty much it, and I'll keep all the screws for the lid in there and just put one in to hold it. Now moving on to our grounding. So I'll put a grounding lug on one of the 2 rails. So I have 3 different sets of PV panels, so I'll have 3 lugs that I'll connect up here. That's bonding this whole array together, and then we'll bring that 6-gauge bare copper ground into the smaller gland connector here, and then we'll just land that into the grounding bus bar at the top. Now this is where I will land my 12-2 Romex, the ground wire for that, to bond then the arrays together, both on the south and the west side of my roof. So we'll just land that, and then with a flathead screwdriver, tighten everything up. So the Enphase wiring is super straightforward, and Project Solar gave me as much cable as I needed. Enphase makes this pre-wired, so you have your watertight connection that's going to go to the 240 out on your Enphase module, and then it daisy chains together. So you just daisy chain each one of your arrays together. Now if you have one large array, you might be doing multiple sets because this is going to max out at 20 amps. Now each of mine, these 8 panels here and 4 panels there, I will be daisy chaining those separate and then bringing those together through those junction boxes that you saw me install, and then down into the attic before going to the actual combiner box that's going to be on the outside of the house. We'll be doing here in just a little bit. Only other thing you're going to have to do, you will have some free ends. One of the free ends going to be going into the junction box, and then for me that's going to be wiring into 12-2 Romex that's going into the attic. And then you're going to have another free end where you need to install what's called a terminator. And I'll show you how these work to make sure everything is watertight and capped off correctly. It's kind of hard to get this wrong with these kind of pre-made connectors, but make sure both the tabs clip in, and then you'll just count out the rest of your connectors, make a cut so you can pull that wire underneath and then place it into that junction box. Then I go through with zip ties and just start securing everything, cleaning it up, and then I'll go back through once I'm all done and start clipping off the loose ends. But here's the terminator. So all you have to do is cut off that outside black insulation and give yourself about 1 inch of the 2 different connectors being exposed. We want those to be exposed because they're going to split inside this terminator, keeping them apart from each other. So you'll make sure you have that nut on and then place within the terminator, and you can look down in and you'll see the two sides. So that will let you know that you're placing the wire correctly, so the wires really do separate. And only tighten the nut. Do not tighten both sides. Don't twist that wire while you're tightening things up. And then we'll just secure it with a couple zip ties here to the rail. And that's really all there is to wiring the micro inverters. All right, so now we're up in the attic and we're gonna bring our arrays together. So I have this first one. This is the larger array, the 6-panel. I've already dropped 10-2 Romex down from the junction box on the roof. And then I'm gonna pull that over to this 4x4 junction box. That's gonna bring my two 10-2 Romex pieces together. One 10-2 Romex coming here, a shorter run, and then I need to go to the other side and then pull 10-2 Romex through the attic, bring those together, and then we'll drop PVC conduit out through the soffit, and then that's when we're gonna connect up with our combiner box and then also our disconnect on the outside before feeding back through to the panel. I'll go ahead and install two 3/8 cable clamps here for the Romex. And I do recommend, don't do it like this. Go ahead and pre-install those in your box before you even mount it down in your garage or an open space. And the attic's gonna be hot, dirty, dusty, so it's just much harder to work in that space. Then we'll run that 10-2 Romex coming from the 8 panels on the southern facing roof, and we'll tighten up that cable clamp to give it strain relief, making sure we have 6 total inches of conductor, at least 3 inches past the edge of the box. Once we got that, then we'll move on to that second run, and that's just going to be those 4 panels on the west side of my roof. We'll go ahead and tighten those down and similarly cut it to length and strip back that sheathing, cutting it off, exposing the 2 conductors and the 1 bare ground. Okay, so now we have our 10-2 all ran out and we can connect everything together in our junction boxes up on the roof. First, we'll just go ahead and land our ground here in our ground bus bar. And then coming from Enphase, we have our black and red stranded conductors. And then for the 10-2, we're going to have black and white, because normally this would be hot and neutral for a 120 circuit. So what you want to do, best practice, is to just put a little red tape on your white, indicating that these are 2 hot conductors, not a hot conductor and a neutral. And then pulling these guys together, I just use WAGO lever nuts. These are the 221s, and specifically these are 613. So they have 3 slots, and the 600 series can hold up to 10 gauge, so it's going to be compatible with our 10-2 Romex. So we'll just match up our white that's be used as the red hot conductor. So the wires really shine with the stranded and solid core, bringing those together just very easy. And then also you can see that you have solid connections through the transparent housing. Now, these are all extra supplies that I bought. So you can look down in the description, you'll see links to the WAGOs, but all the other extra supplies that I needed just for your reference to help out on your own project. But it makes quick work of bringing everything together and also makes it extremely serviceable in the future. You have an open wire here, that's okay, that's not going to hurt anything. And now we can go ahead and put our cover on. So now we're going to start placing the Enphase Envoy, which is the combiner box, but really also the whole smarts of the operation. That's going to go up through the soffit into that 4x4 junction box in our attic. So that'll bring some 10 gauge THHN wires. So that'll be a black, red, and green. So our 2 hot conductors and a ground comes down to the combiner box. Then we mount a disconnect box. I've already mounted some PVC bodies here, which will help me pull the wire. And then this one on this side is gonna go directly into my main panel, which is gonna be right offside this meter base here. So I need to locate that. I need to know exactly where can I punch through to the panel to get access prior to mounting the disconnect or the Enphase Envoy. So what I'll do is I'll take a long drill bit from inside my panel. And remember, if you're not comfortable doing this, if you can't do it safely, if you don't know your local code, go ahead and hire this part out. But if you are comfortable, we'll get inside that panel, drill through, pop it out this side, and then we'll kind of drill out those holes so we can mount this body going in, and then mount the disconnect and start piecing in the rest of our system right here on the side of the wall. Now I'll go ahead and drill from the panel out with this long drill bit so I can locate exactly where that's going to come out. When I know that, then I can go ahead and use a hole saw and get that PVC adapter installed there, which I'm gluing up now, which attached to my body that goes into the main disconnect. Now I go ahead and mount the 3 screws here, but I do notice that those screws are not holding really onto anything because this does not have any sheathing or plywood on the outside of the house. It's just fiberboard. So I'll show you how I'm going to address that here in just one second. But now I need to drill that hole and start to get the PVC pipe up into the attic through the soffit. So I go ahead and stick that up there, and I missed the install of this, but you'll see the finished product of that 3/4 inch going into the 4x4 box in the attic. Now I'm going to take some 1x3s and actually connect those to 3 studs, putting 3 total boards in there, and that's going to give me a screwing surface for the disconnect and also the Enphase Envoy, the combiner box. And now I'm just dry fitting all of the PVC fittings, and then once everything fits up, I go ahead and go back through and glue everything and get it finally in place. With my last connection here, now I have that sweeping 90 and complete our install, and now we're ready to pull wire. We'll have 3 10-gauge THHN wire we'll pull through this 3/4 inch PVC. This is by far going to be my biggest one with 180 degrees of bends. Shouldn't be too bad. It's about a 10 to 12 foot pull, but I am doing this by myself. I do recommend having somebody pushing in the attic and then you're pulling from the outside. That'll make it a lot easier. Now, one other thing, I have my fish tape already up into the box, but a lot of us as DIYers don't have a lot of experience bringing together the THHN wires, so it doesn't catch on anything. And also none of the wires will pull out while we're doing the pull, because you might have to put a lot of force on that. So I'm going to go get mine set up, but then Joel Walsman from a channel called Electric Pro Academy helped me install multiple things over the years. He's a master electrician, and he's going to show you the best practices in tying those together with electrical tape.
I've got a total of 4 conductors to pull through, 2 hots, neutral, and a ground. I'm going to stagger the ends of those conductors a little bit so that I'm not creating one big knob that's going to catch on the fittings through the pipe. And then I'm going to double up my ground, so I've got a good solid hook, and it is going to be taped all the way back. I don't want that pulling out free from the rest of the conductors to where they're left behind. And I've got to pull everything out of the pipe. It's got twists and tangles in it. It's nasty. Got to lock this in as tightly as possible. And this is exactly where electrical tape is notoriously beautiful. It's got that stretch which applies tension to the conductors and prevents pullout. Don't try any other kind of tape. You have to use a good quality electrical tape, like Scotch 88. And here's what the finished product looks like.
So I got those 3 wires taped off, and I have it started so it's actually past the bushing, and at least we're past that resistance. So now I'll just pull it from here. Should be an easy pull, but if I might have to jump up into the attic just in case the wires start to coil up and give me some resistance. Again, a 2-person operation is the best. Nice, nice. Super easy pull. It's not always that easy, but every once in a while you get one that's nice and easy to pull through. So I just cut these guys off here, making sure I have plenty to go within the Envoy here. And now I'm going to go up and complete that 4x4 junction box in the attic, and then we should be done with our roof, done with our attic, and now just tying everything together here on the outside of the home and then inside the main electrical panel. So we'll go ahead and cut our THHN 10 gauge to length here and also strip everything off. I'll be, again, using WAGO lever nuts, and specifically the 613. You'll see a link in the description. Now I do have to double some up here because I have 4 ground wires and I only have 613s, so I had to get a little branch ground there to bring 2 of those together to have enough slots. And then again, like we did before, let's go ahead and label those white, usually neutral lines, but they're hot conductors for us. So let's label those with some red electrical tape. And then we'll finish off bringing together the black hot conductors and go ahead and put our plate on. Now going back out, I'm gonna bring that 20 amp 240 breaker. I only have 1 of those, and this unit could take up to 4 20 amp breakers, so we're not even coming close to scratching the capability of this Enphase system. but we'll land our 2 hot conductors after doing our ground first. It's best practice to always land your grounds first when you're wiring stuff up. So we'll bring that other cut to length. And I'm really just working then back into the main panel. But first, before bringing together the disconnect, I want to run my current clamps. These monitor the load, the overall amount of power coming into your home, and then it helps the Enphase Envoy know what am I producing from a PV perspective. There's a small black circle on the left-hand side of the Envoy. You'll see I passed 1 conductor through that. So that monitors how much PV power are we creating. And then this will monitor how much are we actually consuming. So you'll get a full picture of your home. Now what I did notice is I used the blue and white and the purple and brown. Actually, it's supposed to be red and black and purple and brown. So there's 3 current clamps, and the blue and white would be used if you had an Enphase IQ battery, which I do not. So I do swap that out here in a second just to be consistent. I think it would have worked, but it would have been confusing troubleshooting later on. Seeing the white and blue would mean you have a battery, not that you're just monitoring one of the legs of your system. So there I'm kind of cross-referencing, trying to figure out what's going on, and I come to the conclusion, oh, that blue and white is not supposed to be there. So I take that back out, swap it out, and now I have my red and black. So you'll land those in the small little screw terminals on the upper right-hand corner. So we'll have 4 wires that we need to land. These are much, much smaller wires, and you'll need a much smaller flathead screwdriver to land these, because really these are just sensor wires. They're not taking any load. So get those in place. The nice thing is you have a schematic right on the cover there for both grid tied and another alternate configuration for this system. So once we have those landed, now let's go ahead and work on our disconnect. Now this is a 30 amp disconnect. It is non-fused. We will not have fuses in there. There's just blades that either complete the circuit or open the circuit. One thing to point out is usually these disconnects do not come with a grounding bus bar, so you will have to buy that separate. You'll see I have installed a 3-position grounding bus bar, because you wouldn't want to have the disconnect where you have hot conductors coming through your disconnect, but you do not have that metal box grounded. That would be against code. So now we have the L1, L2 going in the Envoy, coming back. We'll start buttoning everything up as we complete that part of the install. And then we'll land our ground first on that bus bar that I installed. Remember, don't forget that part. Don't just bring your 2 hot conductors in here. Make sure you have the box grounded. And then we'll land those with stranded wire like this. Make sure that you torque those down and then wiggle the wires a little bit and then torque them down again. And just passing through those 3 conductors from the panel. And then I will bring those into the disconnect, landing ground first. And then we'll complete those 2 other hot conductors. And I do flip this disconnect to the off position, just so I have everything off as we go back and complete our circuits to our panel. Now inside the panel, I will go ahead and bring the ground in. Remember, at your main panel, your neutrals and grounds come together, so you'll be just bringing that into a common bus bar. And then once that's in place, I'll connect my 20 amp 240 volt breaker all the way at the end. You want to as far away from the main disconnect as possible, and then land your 2 conductors, and then you can go ahead and put on your cover. Now I'm going to start installing the panels. This is kind of the home stretch here, but don't forget you can actually turn on your Enphase Envoy and go through some of the troubleshooting in the Enphase Toolkit app just to make sure you have connectivity and everything starts checking out. It's a really, really good app to kind of walk you through each of those steps. I did that and everything did check out, so I'm comfortable now going on to getting the panels in place. Now I still need to get inspected and also approved by my utility, so not everything's completed, but we're ready to at least get the panels and do the last big part of the project. Now you want some side cutters here for all the zip ties that you've already installed for the wiring, but also the zip ties you might have to do for your MC4 cables to do wire management, but don't leave the zip ties long. Go ahead and cut those off, flush without a sharp edge that cuts your fingers. So you got to watch out, but little micro side cutters do a really good job of that. There's not too much hardware in this part. Really, you have one mounting bolt. That's gonna be your mid clamp between two units, but it's also with a spacer that's appropriately sized for your panel's frame thickness. It's going to be your end clamp. So you put those spacers on when you have that end clamp, and that's how it will properly secure down. There's also a small little ring at the bottom that cuts into the frame itself, and that's what helps to bond everything together and connect it up to the 6-gauge bare ground that we installed earlier on. Now this is a pretty physical part of the job, so if you have some help, I would recommend to try to get that now. Maybe they can even hand it up to you opposed to you having to go up on a ladder. And please do not go on a ladder if you have any wind. These solar panels turn into sails very, very quickly, and it is extremely dangerous to be walking up a ladder holding a panel with one arm, and then the wind starts to hit that. At minimum, it takes the panel and throws it, and more likely, it might actually bring you off the ladder. So please take caution, especially if there's any wind. It's super calm right now, so it's a good time for me to get these 12 panels up on the roof and start to install them. So we'll start off with that first one, just confirming that we're open on our fire lanes. 36 inches to the ridge, 36 inches to the outside of that roof. And then once we get that and everything's lined up, then you can start securing it down. And it'll take you a little bit of time to get used to how exactly to tie off those wires, keeping them off the deck. You want to keep them off the asphalt shingles as much as possible. And then you'll start to progress through. If it's hot out like it is today, plenty of water, take your time. If you're doing this by yourself, you want to make sure you're doing it safely because you can get tired pretty quickly hauling those panels up. But when you plug it in, you should see that flashing light on each of those micro inverters, indicating that it's at least getting power, and then we can do some additional commissioning and validation later on once everything's plugged in. So now we're moving to the west side, only 4 panels here. I did need to move my ground wire on the rails to make sure it was tucked underneath those 2 last panels that I'm putting in right now. And then we'll finish off the total of 12 panels here and secure everything up. Well, we did. Now the system's fully installed. I still do need to get my inspection next week to make sure everything is good electrically, and then also commissioned by my utility, and that can take multiple weeks, even though I'll try to push it out. Don't forget to subscribe to the channel because I will do an update on the system once we're actually producing and kind of do some return on investment calculation. Remember that link in the description of Project Solar if you're interested to do a similar DIY project on your own home. They were a huge help and helped me save a ton of money by taking on the labor myself. Now let me know any feedback, good or bad, you have down in the comments below. I'm sure I did things that are incorrect and also a lot of things that were not best practice or just much, much harder the way I did it compared to the way a professional would do it. But some of those comments will help you avoid those same mistakes. And then also, if I have something wrong on my inspection or if there's any issue with the utility, I'll put that in a pinned comment, that first comment right below the video. So as I learn more about the system, it calls it out for your own information and to help on your own project around your house. Now, if you want to get started on a little easier type of project, doing a solar shed is a great place to start, and it's completely off-grid and just a much lower barrier of entry. So you can check out this video right here on a little shed we put together a few months back. And as we get the system up and running and approved by the utility, I'll give an update with this video down here, so you'll have the complete picture depending on when you're watching this video. So thanks for joining me on this one, and we'll catch you on one of those next videos. Take care.